DHCP, otherwise known as Dynamic Host Configuration Protocol, is with us in order to allow us to allocate IP addresses and IP address configuration. Now, we can obviously statically assign every single machine in the network with an IP address, a subnet mask, a default gateway, some DNS servers, Win servers if they're still floating in your network somewhere, and there's a whole lot of other configurable options. Those, of course, are just the most popular. Well, to handle this statically is actually a pretty big job, and there's a lot of room for error, whether it's administrative error or whether or not it is an overlap and we have some duplicate configurations. So based on that, we use DHCP. DHCP will allocate the IP addresses and the configuration to the clients, so the clients boot up, request an address, and get one. But it also tracks who has what IP address, so that way we don't have any overlap. Now, what also helps quite well with DHCP is, let's say globally you're going to change what your default gateway is going to be, or you're going to change or add another DNS server. Well, instead of visiting every single client in the network, we can very easily go to the DHCP console, go to the scope options, add or change or remove any of those options, and the next time these clients renew, they will receive the options themselves. So DHCP allows us all of that flexibility in management and also gives us a single place for updating. We can also have reservations with DHCP, so even if something needs a static address, if we reserve it by its MAC address, it does get the same IP address every single time, but the address is actually managed from the DHCP console. So again, a way to manage things all in one central location. Now on the client side, many devices can be a client. The obvious are clients, the PCs, the laptops, the servers, the printers even, but those DHCP clients can be really any network device. So it could be your smartphone when you tap into the Wi-Fi, or it could be a switch or a network boot client. So anything that knows how to boot up and request an IP address, which is the majority of any network device, all of those can in fact be a DHCP client. Let's go through the components of DHCP server. We have the server service. Well, the server service is obviously a listening service for the client requests, but the server service also has its own client service. So a server can be a DHCP server or a DHCP client. Now, with the server service, we have the auto startup on a Windows host. So that means every time Windows boots, the server service will kick in for DHCP. And again, that's the component that will be responsible for all the IP address allocation. Another component is the DHCP database, which means we have all of the configuration data, including who has what IP address. So we have all the information regarding the IP addresses that are leased. Its default location, although you can move it, is in the system root under system32/DHCP. We also have a component for the DHCP console. Now, the DHCP console is your main administration tool. This is where you're going to view the configuration and some client information. And the DHCP console can not only be seen on the DHCP server, but you can install it as a tool on a client machine with remote service administration tools, otherwise known as RSAT. Now, if you want to remotely deploy this particular tool, it does have to be on a Windows 8 machine if you're going to use this with RSAT. We also have a component called DHCP authorization. Now, DHCP authorization means when you install a DHCP server, an enterprise admin has to authorize a DHCP server on the network. If it is not authorized, it will shut the service down and it'll be unable to answer requests. This, of course, is a security feature, so just not any administrator can create a DHCP scope, put it out on the network, and then have it actually handing out IP address, which may not necessarily be the right one. So again, it has to be authorized by an enterprise admin in the domain, or the DHCP service will shut down. And authorization is a simple step. It literally is a right-click and authorize. It just has to be done by the right person. Within DHCP, we have something called a scope. A scope is essentially a range of IP addresses and any of the related information. Now, any of the related information can be obviously the optional information, but the required. You wouldn't give out an IP address without a subnet mask, an example. So IP address and submask is going to be your minimum, but we can have a default gateway or DNS servers or all sorts of other information depending on what you need. So an actual DHCP scope has to have a scope name and description so that we know which scope is which and what the purpose is. It'll have a range of IP addresses and a subnet mask. Now again, that's all you need for a client to be on the network. You might be thinking a default gateway is a requirement, but not necessarily. Without a default gateway, clients can still communicate on the network. They just can't get out of their own subnet. Now again, the optional configurations could be anything from the duration of the lease to the DHCP options like default gateway or DNS. But we also have an optional configuration called exclusions. So if I was to go ahead and create a scope, and that scope contained 200 addresses, but somewhere in the middle was an address that was already in use by a device on the network, and for whatever reason it couldn't change, I could have a scope with a whole range of addresses, and I could exclude that one in the middle so that the printer could keep or device could keep whatever IP address it needed. Now, with the other options, there's some other options just to think about. A domain suffix. A domain suffix is what gets appended on the end of their host name. We can add more than one domain suffixes for search. So as we're querying DNS servers, we can look at more than one DNS zone, but more about that later when we talk about DNS zones. We can have WINS or NetBIOS name servers. And also with scopes, we can decide the options, but options also have different levels. An option can be global to all scopes. They could be at the scope level. We can create a class ID level, which could be hardware, software defined, or it could be at the reservation level. So if I reserve an IP address and configuration for a client, then that reservation can have its own options, its own default gateway, its own DNS servers. So we can create those options at many different levels. The default level and the most common level, of course, is at the scope. Now, you can configure more than one scope on a DHCP server, but the server has to be connected directly to each subnet that the scope is answering to, and if it's not, you'll have to deploy a DHCP relay agent in order to relay it over to the appropriate server. With the DHCP, there is a lease process. Now, the lease process, in its simplest form, is a client asks for an IP address, it gets one, and it gets it for a duration of time. So that's what's known as a lease. Now, the default lease is 8 days. We can change that to be unlimited, or we can change that to be 2 hours. It doesn't matter. So the lease process is when you get your configuration. Now, the things to remember about the configuration is there's technically 4 different stops. So the client who doesn't have an IP address, all it has is a physical address or MAC address, will send out a broadcast. That broadcast is for any DHCP server that's listening. Now, once a DHCP server hears it, they can actually send a DHCP packet back to the client. Now, it doesn't have an IP address, so it basically broadcasts it back, so it's going to hit that MAC address. It's going back to the MAC address of that server. So the server will offer a configuration. The client will accept the first one. So we have another packet that's traveling. And then from there, the server responds with an acknowledgement, almost a final confirmation that, yes, this is going to be the information. Now, if more than one DHCP server has offered an IP address, then the rest of the servers will send out what is known as a NAC. That's N-A-C-K, or a negative acknowledgement packet, basically rescinding their offer. So once that acknowledgement is received, that client has that IP configuration for the duration of the lease, again, 8 days by default. Now, what happens with this lease process is every time the client reboots, then it's going to look for the default gateway. If it can't find it, it's going to resume the entire renewal process again, even if the lease is not up. Now, the reason for this is a lot of computers, like laptops or mobile devices, they move from network to network to network. So if you reboot it, it realizes by the gateway that it's no longer on the same network, therefore it's going to start the whole process again. Otherwise, if there's no reboot, or if every time it reboots it contacts the gateway so the lease is fine, halfway through that lease the client will attempt to renew. This process is at 50%, and then it goes to 87.5%, And then, of course, when the whole lease is expired, it goes through the whole process again, assuming it hasn't automatically renewed. Again, so the renewal is done at the end of the duration, actually halfway through the duration, 3/4 of the way through the duration, or anytime it reboots and it can't contact the gateway. There's a lot of different options with DHCP. We can create what is known as super scopes, which are more than one scope essentially tied together. We have our multicast scopes. So instead of an IP address to a directed client, multicast allows them to actually do a one-to-many type of broadcast. We have options that are specific to DHCP version 6, and some of the other options we can configure is really more about the high availability. As a matter of fact, with DHCP finally in Server 2012, notice the finally, we have some failover components that are outstanding so that if one DHCP server fails, another one can automatically take over. So we will talk about that shortly, but for now, in general, those features have been here, and that was a whole lot of manual steps that didn't work as smoothly before, so this is actually a good thing. We have failover, we have split scopes, and we also have DHCP name protection where we can protect certain configurations for clients. DHCP does integrate with DNS. Now, DNS, in its simplest form, is taking a host name and mapping it to an IP address. So if your IP address changes all the time, it's important to have DNS always updated. Now, we do have DNS that allows not only the update of host records, but also have the pointer records and the reverse lookup records. And again, who updates it? Which records do they update, and when are those records deleted are part of some of the questions. So we have something known as DHCP option 081. Now 081 allows the server to actually own the DNS records. So DHCP is doing all the work on behalf of the client. It'll create the records, it'll also delete the records when the IP address expires. Now we can also go to the DNS tab of DHCP. On the Properties node, you will see that there's what's known as a Protocol node, and here you can configure this per scope. Now, we have DHCP server that updates a DNS client. This is only if the client address requests it. It can do the host record, the pointer record. The default could only be the pointer record, and the client will actually do its host record or its A record. But upon lease expiration, the record gets discarded, and so does the pointer record.